Hello there, my name is Nátali, and today I'll be talking about tidal energy. This here is the script of my presentation for today. I'll be going over the concept, history, technology, advantages and disadvantages of tidal energy. The concept of tidal energy is the generation of electricity by the movement of the tides. That can happen through the currents or through the difference in height between waves and or between high and low tide. This movement creates kinetic energy that can be used to generate electrical energy. The energy from the tides is a clean form of generating electricity because during its process of production and consumption, it does not free particles or gases that cause the greenhouse effect or global warming. Now onto the history of this form of energy. France is considered the pioneer on the use of tides to generate electricity, starting the first ever tidal energy power plant in 1967. It was the biggest tidal power plant on the world up to 2010 when South Korea made the Shia power plant, overtaking the French spot on the leadership of this kind of clean energy. There are two types of technologies that can be used in this type of power plant. Both these technologies work, creating kinetic energy that is used to move a generator, creating then the clean energy. The differences are in how they create the movement, the placement, and the construction of the devices. The first type is based on different devices that are placed under the water and work by the movement the current generates when it passes through them. There is mainly three types of design for this equipment. Tidal fences that, as illustrated by the first image, do circular motions horizontally. Tidal barrages that depend on the principle of communicating vessels to work, so that when one side of the barrage has a higher level, the natural path is to move water to the lower side, trying to balance the level on both sides as illustrated by the middle picture. The last is the tidal turbines that work through vertical circular motions and are the most commonly used around the world. The biggest example for this kind of technology is the French power plant. However, other countries like England, Japan, and the USA use it too. The second type of technology is called the wave clapper. It is a floating device held by a mechanical arm that is placed on top of the water and is moved by both the waves and the difference between high and low tide. The current design used in Brazil is the one on the left, where there are less modular units, but they have a bigger size. While in other countries, such as Israel and Mexico, the design used is the one on the right, where there are more modular units that have a smaller size. Canada is one of the few countries that use a mix of both types of technology to create tidal energy. It is important to mention both these technologies have mechanisms to identify possibly dangerous situations, like big storms, tornadoes, tsunamis, and others. When they do identify one of the situations, the device can either retract or extend, depending on the scenario, to protect the equipment from any damage that could be caused. This identification is normally through sensors that can see the height on the waves, the speed of the water, among other identifiers, but it can also be activated manually from the base on the coast. As soon as the situation passes, the machines once again can either identify automatically or be manually operated to go back to their normal position and return to their usual functions. Like every other technology or idea, the tidal energy has its advantages and disadvantages. Some of the positive traits are that unlike solar power that is dependent on sunshine, or even wind power that is mainly functional during the day, the tidal energy is not time-based. The difference between day and night isn't significant enough to affect the resulting energy production. Next, The materials needed to build the power plant are not expensive. Both the devices on the water where the turbines or wave clappers are, or the base on the shore where the energy is transformed, do not need any rare or too specific materials. This not only cuts back on the price of building this kind of power plant, but also makes that the materials are easy to find, without the need to import any particular piece. The cost is even lower, and there is less pollution produced because of the lack of need for transportation. This is also noticed when you consider the fact that 2/3 of the population live near bodies of water, and since these places are not hard to access, the transportation and exploration of the sites are not hard and occasionally not even needed. In addition, the tidal energy is a very potent one, being able to create several times the amount of energy a wind power plant can, by example, as the water is more dense than the wind. Theoretically, we can extract around 40 megawatts of potency per kilometer of coast just from low waves of about 1 meter high, and from higher waves of around 5 meters high or more, the generation is of 1,000 megawatts of potency per kilometer of coast. Lastly, the waves are created by a sum of numerous factors of natural elements, such as the sun, the moon, the wind, the currents, the Earth's rotation, etc. When you consider all of these elements and the substantial information we have about them, it is relatively predictable behavior pattern of waves, making the tidal energy a very stable type of power plant. Now, on to some of the disadvantages. Despite not being really affected by the differences between day and night, there are factors that can alter the energy production. The aspects that are meaningful when the technology you are using is the wave clapper are the height of the waves, the velocity of the wind, the frequency in between waves, and the tides. Similar to that, when you consider the other technologies, the topography, temperature of the water, season, and speed of the current must be taken into consideration. So, both the conditions of waves and currents can alter the process, but, like mentioned previously, are predictable factors. Next, despite the price of construction being a small one, the equipment that is placed in contact with the water needs more frequent maintenance. This is caused by the salt present that can damage the devices quicker than fresh water would. Again, the materials are not rare or too expensive, and the base on the shore will need much less replacements or other forms of maintenance. In addition, the navigation is also a problem of the tidal energy. Where the underwater devices are placed, the boats or ships will either be completely stopped from cruising this particular area or will need to alter their course slightly as to not hit or damage any parts of the power plant. When it comes to the wave clappers, since they are placed above water and closer to the shore, they only present a problem when it comes to docking the boats, which can be prevented by decreasing the number of modular units and inspecting their placement. Like any other clean energy, it has some effects on the wildlife. Any form of marine life would have to move around the devices and could possibly be scared or hurt by them. And, considering the placement of the power plant, it could disturb natural habitats for certain species or get in the way of their migratory path. Therefore, a thorough study of the topography and marine biology is essential before installing the tidal energy power plant. Having said both positive and negative aspects of this energy, it is undeniable that with the current levels of pollution and exhaustion of other means, it is likely this type of power plant will be used more and more in the future. Here are the credits for my presentation. Thank you so much for watching. Goodbye.